Next, the sine rule, cosine rule. So, two properties that we have discussed. One is the sum of angles is 180. Right? The other is the triangle inequality theorem, which is talking about the side lengths. Generally, if the question is only focusing on the angles, this should be sufficient for you. If the question is focusing only on the sides and no other information given, maybe this is something that you could apply. But what if there is a mix of the angles and the sides? Right? That's also a very possible type of question that you could get to see. So sine rule and cosine rule is where, are things which would help you to solve questions when you're trying to link the side lengths and the angles, interior angles. How? So what is sine rule basically saying? If I go by this, right, the way we write is C and B, right, as I said, side lengths opposite to the vertex A is A, BC is A, this is C and this is B. So sine rule says A by sine A is equals to B by sine B equals to C by sine C. So these C's are small. These are side lengths by sine of angle opposite to that. So this is the vertex A, right? A by sine of angle A, that is this angle, is equals to B, that is this length, by sine of this angle equals to C, that is this length, by sine of this angle. This will always be true for any triangle. And that's what the sine rule is. Here we are connecting the side lengths and the interior angles, right? So one fundamental thing before we dive deep into this, to just sort of revise, sine you need to know up to a decent level. So 0, 30, 45, 60 and 90. What is sine 0, 30, 45, 60 and 90? These are the angles that are required, to know and solve problems. If you know the values, that's good. Otherwise, the easier way is, break it like a square root of 0 by 4. Then it is 1 by 4. Then it is 2 by 4. Then it is 3 by 4 and then it is 4 by 4. If by chance you don't have the ability to remember, I don't remember these things, so then you can try to create it like this. The standard angles are 0, 30, 45, 60 and 90. So square root of 0, then increase it to 1, then to 2, then to 3, then to 4. So 0, 5, 4 is 0. Square root of 1 by 4 is 1 by 2. Square root of this is 2 1 the 2 2 the, so 1 by root 2, root 3 by 2 and this is 1. Right, 0, 1 by 2, 1 by root 2, root 3 by 2 and 1 are the angles for the sine. Cos is just the reverse of it. Right, what am I talking about? Sine 0 is cos 90. Sine 90 is cos 0. So I'll write 1 here, cos 0. Cos 30 is root 3 by 2. Cos 45 is 1 by root 2 and cos 60 is root 3 by 2 and 90 is 0. Sorry. This is 1 by 2, right? Cos 60 sine 30, that's 1 by 2. So tan is basically sine by cos, right? We can do it to find out these angles by dividing. Another useful property in applications in geometry is this: sine of theta is equals to sine of 180 minus theta. What do I mean by that? I have only covered up to 90, right? What if I need to find out sine 120? Sine 120 is same as sine 180 minus 120, that is sine 60, right? Which is something I know. Sine 150 is same as sine 180 minus 150 is sine 30. These are the useful things that you can use to solve this, right? So A by sine A, B by sine B, C by sine C can be used. Let's say I know that this is angle 30 degrees and this is 6 centimeters. And I'm trying to find the side length B and I know this is 45. Okay. Let's say I know this, I know this, I know this. Now how could I can find this? Okay, let me take slightly easier for us. So let's take 60 here. Okay. So 2 angles and 1 side is good enough for me to find out all the 3 angles and all the 3 sides to complete the triangle. How? See, this is 30, this is 60. Automatically, this has to be 90 because the sum has to be 180. Right? So now what will I do? I'll apply the sine rule. 6 by sine 30 should be equal to B, which is what I don't know, by sine 60. Right, now I'll solve this. Right? Sine 30, so this will translate to 6 by sine 30 is 1 by 2. And B by sine 60 is root 3 by 2. This get cancelled out. B is 6 root 3. So B will come to be 6 root 3. Now I could also use the same logic for the C as well. So 6 by sine 30 is A by sine A equals to C by sine 90. Sine 90 is anyway 1. So C will be 6 by 1 by 2 is basically 12. So third side is 12. And that's how I can actually fill the entire triangle if I know two sides and one angle are two angles and one side, right? Using the sine and sine rule. The cosine rule is basically slightly similar with respect to what it will do. It's just that the formula and what we use is slightly different. So third side, c square is equals to a square plus b square minus 2ab cos c. Right, that's what we will write. So c square equals to the other sum of the other two sides minus 2ab cos c. Right, here anyway c is 90 degrees. So automatically, you know the Pythagoras theorem, the opposite is c square is equals to a square plus b square, which is what even this will say, because this is a square plus b square. Cos 90 is 0. So this will become 0. So that will turn out to be a square plus b square, which is what the Pythagoras theorem is, right? But this is something that is useful for all the angles. Let's say I am trying to find this. Okay, let me find this one, right? B. So what is this? B square should be equal to a square plus c square, basically sum of other two sides, a square plus c square minus 2ac into cos of b, right? Because angle is this, right? Cos b. So what is a square? I know a square is 6 square, c square is 12 square, I found that. Minus 2 into 6 into 12 into cos 60, right? Cos 60 is the angle BC. Cos 60 is 1 by 2. It's cancelled out. So this will turn out to be 6 square is 36 plus 12 square is 144 minus 12 6 is 72. So 72 plus 144 minus 72 is also 72 plus 36 is 108. So finally b square is 108 and b will turn out to be 36 into 3, that is 6 root 3, which is what we found to be b, right? So this is also a useful formula. Cosine rule, basically one side square is equals to sum of the other two side squares minus 2 into those two sides product into cos of that angle opposite to this angle. I need to take this angle which is relevant to this, right? AB and AB is product 2AB into cos C, because I am trying to find the C square. Because I am trying to find B square, it's A square plus C square minus 2AC into cos B, right? That's something that you can use to find the side length. So these two formulas would help you to link the side lengths and the angles, interior angles. Okay, that's the application of this.